Hello everyone. So this second video is the continuations of my first one on the ambiguous case, and so now I just want to show you an example of the ambiguous case where in this example you are giving the triangles ABC where the angle A is 30 and the length A is 25. And another length B is equal to 30 cm. So again, make sure that you take notes of the known pairs. So now we have an angle A and the length A. So on my draft triangle, okay, I'm going to draw my draft triangle first, long, short, and then I enclose. And I always put my known pairs. Starting from the left, okay, so I always put my known angles here. I label this as my angle A. Length A opposite to angle A is 25, and the other length B, I always put it on top here and not down here. So this is going to be my angle B, and this is going to be my angle C. So if you recall the step that we need to do, we always check for the height of the triangle first to make sure that this is a valid triangle. Using the formula that I showed you earlier to find the height, you always take the length B, the other length B, 30, times the sine of the given angle, 30. So 30 times the sine 30 will give you 15. So if the height is equal to 15, then if you look at this right angle triangle here, so it does make sense that the A is greater than the height. So that means I can go further to test the length A to see if the length A is greater or smaller than the length B. And as you can see here, my length A is less than B. A is less than B. So therefore, this is where the ambiguous case is happening. Okay, so that means in this triangle here, the way how I draw it, there is another ways of drawing it when the A is less than B. Okay, so I'm going to have the two cases shown to you later. Okay, so from the first case, okay, so this is my first case. My draft triangle becomes my first case now because everything fits. Okay, so this length A, this length B is longer than the length A. So it does make sense now. My draft triangle that I start with the long and the short, so this satisfies. So that's how I don't have to redraw my triangle for the first case here. So in this case one, triangle ABC, I need to solve for the missing length, which is the length C or length AB. And what is missing is also the angle B and the angle C. So those are the three missing informations that I need to solve for this triangle ABC. So just to quickly remind you that in order for me to solve for the missing angle from this triangle, because I have a known pair, so sine 30 over the length 25, so this is my known pairs, and all I have to do is set it equal to, if I want to solve for the angle B first, so I take the sine of angle B and over the length 30, because this is the length that I'm given. So I must do this step first. So when I solve for the sine of angle B, I take the cross multiply. So I take 30 times the sine 30 and then divided by 25. So very quickly, when I do the inverse for the angle B, I can determine the angle B to be approximately equal to 37 degrees. Okay, now you can confirm my calculation here using your calculator, but be sure that you are on the degree mode first of all. And then when it comes to the degree, we always want you to round the degree to the nearest whole number. Okay, so we don't want to deal with a decimal angle. So make sure that you always round the angles at the end of your calculation to the nearest whole. So once you know that the angle B is equal to 37, then we can quickly calculate the other angle, angle C, by taking the difference when you add the two known angle, the 30 and the 37 that we just calculate, and subtract it from 180 because all interior angles should add up to 180. So when you do that, you can quickly calculate the angle C to be 113 degree. Okay, so I don't need you to use the sine laws again for the angle C, like what I did with the angle B, because once you know that once you have two angles, then the other remaining angle just a difference between the sum of the two, and subtract from 180. Okay, so this is the fastest ways to get the other missing angle. And now when it comes to the when it comes to the other sine length, so the length AB or the length C, okay, we know that we can, sorry, we just, I just redo this step here, but I just want to show you how we can solve for the length AB, okay, and it's by taking the known pairs, again, sine 30 over 25, set it equal to sine 113, which is a C, okay, length C, the angle C, sine of a 113 over length C, which is the AB. Now, I'm going to rewrite this using C instead, okay, because length AB is the same as the length C. So I'm just redoing the steps over here. So when I solve for the C, I just take the cross multiply. So I take 25 times the sine of a 113 and then divided by the sine of 30. So I get the length C or length AB as a 46.03 cm. Okay, so this is how I'm going to solve for the remaining length and the missing angle. Okay, now so this is my case 1, my regular case 1. Now the different ways of drawing this, okay, will becomes my case 2. So if you recall how I can just move this length A inward, okay, so imagine if from the case 1, if I move this length A inward, so this is how I can redraw the diagram for the second case down here, okay? So if I'm moving this length A inward, so now I'm giving myself this new length A still be equal to 25 cm. I still label this angle A here with the 30, and I still label the 30 as my length B, okay? But down here, I don't call this B anymore because this is the second case or the second ways of drawing the same triangles. So I'm going to call this a B prime instead, okay? Now, how do we solve for the missing length now is the AB prime, okay? And that is still is the same as my length C, okay? And this is still my length B, okay? And I still have the length A of a 25. Now, in order, as you can see, once I put the length A now inward, then that is giving me this as an obtuse angles, okay? Because if I extend the space a little bit, and you know that this length A was there before, but I just put it inward, okay? But because they're the same length, okay? And I just want to remind everyone that in if you have a triangle that with the same length, okay? So let's say if this is my A from before, but this is my length A from after I put it inward, okay? But because they're the same length, so that means the angles down here, they must be the same. So knowing that angle A, okay, sorry, this is not angle A. This was called angle B before. And this is my angle B primes after, okay? But they should be getting the same angle here, okay? But this angle that I'm talking about here must be the same as the angle B that I have from before. Okay? So what's happening is that angle B from my previous case, my angle B is 37. So my angle B prime, okay, the inside one, this one here, must be equal to 180 minus the 37, because the 37 is the angle that I have from the previous, okay? So for the angle B prime, okay, I cannot use the same method as what I did before, because if you keep using the sine law methods, you will end up an angle here that is not an obtuse. You will be getting 37. Okay, if you use a sine law for this diagram, the angle B here, the B prime, you will still end up with the 37, which it doesn't make sense because this one obviously is greater than 90. Okay, so in order for you to find the angle of this B prime, okay, I want you to always take the 180 and subtract the angle B from the case 1. So that will give you a 143. Okay, 143, because any angles along the same straight line should add up to 180. And because once we get the angle B prime, then I can figure out what the angle C is going to be. And again, I follow the same method. I take the 180, subtract the sum of the two known angles, so the 30 and the 143, then angle C must be equal to 7. Okay, so that's how quickly I can determine all the angles. And then to get the length C, or the length A B prime, I need to use the sine law. Okay, so I take the known pairs. So sine 30 over the 25 equal to, now the angle C is a sine is 7 degree. So I'm going to take sine of a 7 degree divided by the length AB prime, or C. Okay, AB prime is going to be the same as the length C. Okay, after you do all this cross multiply, you take 25 times sine 7 divided by the sine 30, and you will get the length of 6.09 cm. Okay, so this is how we are going to solve for the triangles for the ambiguous case. Okay, and you need to practice more for that. And now I'm going to quickly finish the second case for the ambiguous case when you are dealing with the obtuse triangle. So I just want you to take a look at the obtuse triangle that I have over here. That usually this is how I would be drawing my obtuse triangle. Okay, and obtuse triangle means one of the interior's angle is greater than 90. Okay, you can only have one obtuse angles in an obtuse triangle, because once you have the obtuse here, then the other two must be an angle that's less than 90. Okay, you cannot have two obtuse angles within a triangle, because then that means then you will not have the sum that's equal to 180 anymore. Okay, so that is very important to make notes of. So when you get an obtuse triangle like this, okay, then there's only two cases really, okay, because if you have the angle A is the obtuse, okay, and then the length A, when you have the obtuse, then that means length A has to be the longest length, the longest sine length in that triangle. All right, so because A is the longest sine length, then A has to be greater than B, or you can say A has to be greater than any other length in the triangle. then there's only one triangle exists, and that will be it. Okay, that will be it. However, if you have the angle A is an obtuse, but A is less than B, or A is less than the height, or A is equal to length B, which totally is impossible. Okay, because if angle A is the obtuse angle, that means length A has to be the longest length. So it cannot be smaller than B, it cannot be smaller than C, or it cannot be even smaller than the height. So where's the height of the obtuse triangle? Well, if you can draw the vertical line from outside, and you can extend the base, and this will be your height as well. Okay, but we're not interested in the height at all on the obtuse triangle case, because when angle A is on the obtuse, then length A has to be the longer side length as compared to any of the length here. A should be bigger than B, A should be greater than C, and A should be greater than H. Okay, so that's why I'm putting all the possible cases here where if A is smaller than any of this length, then no such triangle exists. You don't even have to worry about it. Okay, so I'm going to quickly show you two examples from the worksheets that in example E, where you are given the triangle XYZ, where the angle X is 120, length X is 40, and the other length Z is 20. Okay, so since angle X is an obtuse, so again, I want to show you, this is your known pair, angle X and the length X. Okay, so on the side, when I'm creating myself this obtuse triangle, if I know that angle X is the obtuse angle, then I'm going to label this as my angle X with the 120, and the opposite of this must be length X, and this has to be the 40 cm. Well, my other Z, 20, I can put it either way. Okay, I can put it here, that's fine. So I can say this is Z equal to 20. Okay, if this is Z, that means this must be my angle Z, and the remaining letter, the Y, must be up here. So this must be my angle Y, and this must be my length Y. Okay, which is a no. Okay, so then only since the angle X is the obtuse and length X is greater than the other length, then that means only one triangle can be drawn. Okay, and then I can try to solve the other one using my sine law method. Okay, but if you look at example F, given in triangle DEF, where the angle E is 144, so this is an obtuse angle, and the opposite length 10.5, okay, but the other length is 12.5. So think about it. Angle E is an obtuse, but the opposite length E is less than the other length, which is not possible. So therefore, I can tell you right away that no triangle can be drawn. Okay, so those are the two main cases for testing the ambiguous cases.